So good evening everyone. This is Vishal from Cypher School. I hope you all are doing well. So today's session is very special and it is going to be very practical and career focused. We will be discussing the DevOps roadmap, like what skill actually matter in 2026, like how modern engineering works and how you become industry ready in just a few steps. So to guide us through this roadmap, we have Abhijit sir with us. So hi sir, welcome to this session. So could you please introduce yourself to the students?
Hi everyone, this is Abhijit Kumar Jha, and I'm a software engineer with about three
Sir,
years.
you are not audible.
Hello, hello. Am I not? Hello, um, hello, hello. Okay, one second. Okay, okay. I think I should be audible now. Hello.
Still, we are not able to hear anything, sir. You are not audible.
One second.
Okay, now you are audible.
Okay, yeah. Cool. So, hey everyone, I'm Abhijit Kumar Jha, and I'm a software engineer with about 3 years of work experience now. And I have been mainly working in as a backend and DevOps engineer, and I've worked for several different companies till now. So today we'll talk about why DevOps is needed and how can you become one, and is it even a good career field for you to go in, right? So, one second. Vishal, can you confirm if my screen is visible or not? Yeah, it is. Yes. So, before going into DevOps, let me
Yes,
just tell you.
sir, we are able to see.
Yeah, thank you.
Yes.
Okay, let me just tell you how we go ahead and deploy any application. Hi Abhishek. Hi Abhishek. So, have one of you ever deployed any application to, let's say, AWS or GCP or any other cloud platform like Azure? Anyone? Have you ever deployed an application? Okay, so I think most of you have not yet deployed an application. If you have deployed an application, you would have deployed through Vercel or Render. So these platforms give you a proper pipeline, DevOps pipeline built in. Okay, so you don't have to build anything, right? But how do you do that manually? Okay, so let me show you a very simple way of deploying. Okay, first you have to go ahead and maybe log in to your AWS account, right? You go ahead and log into a AWS account, you SSH into a server, right? That's what I mean by logging into AWS. And then you have to somehow, yeah, okay. Then you have to somehow bring your code on AWS, okay? Then you have to somehow bring your code on AWS, okay? Bring your code to AWS. And there are several methods of doing this, right? Yeah, in EC2. So first you SSH, then you have to bring your code to AWS via either by copying it, or you can use tools like GitHub, right, where you can use it to pull your code base. Then you build, right? Build. The meaning of build is that you convert your application into an executable format. For example, Abhishek talked about jar file over here. So let's say if you have a Spring Boot application, it first needs to be converted into a jar file that then gets executed. Okay. So the next step is build. Okay. And mind you, you're doing all these steps manually, right? By basically executing commands on AWS. Sharma Abhishek. Okay, I'll come to that part soon. Okay, and AWS does not cost a lot if you use it carefully. Okay, so I'll tell you how to use it. So third is going to be build, and then you finally go ahead and run your application. Run your application in the EC2 instance, right, or wherever you are, whatever service you're using for AWS. So these are the four major steps: login, bring your code, updated code, build it, and then run it on the instance, right? But as you see that there are several, you will see that there are several problems in this. Okay, there are several problems in this. Okay, now first of all, it's completely manual. Okay, it's completely manual, and you're just deploying it on one server. Okay, if you know about a bit about system design, maybe, right, you will understand that a single server a lot of times is not what you need. You need a cluster of servers. Okay, so will you go ahead and do it on 10 servers if you have 10 servers? Maybe not. Okay, right? And one more thing, see over here. Whenever you will restart your application will first go down, right? So let's say you have a set of users. Let's say you have 1,000 users. So the 1,000 users will not be able to use your application till the time it's redeploying, right? So yeah, you need. Yeah, yes. I'm talking about horizontal scaling in this case. That when you scale, right, when you have multiple servers, right, your applications will go down, and whenever you are trying to restart it, right. So this is definitely not a production ready, I would say, way to distribute your applications. Okay, there's one thing that you built your application, that you built a service, right, and there's another thing to present it to the user, deliver it to the user, right. DevOps is that delivery pipeline, how you deliver it to your users so that it cause minimum level of inconvenience, right? So there's a term called as zero downtime deployment, right? That I want to deploy, but there should not be any downtime. Okay, so we'll talk about how all these things are achieved, and how this deployment happens at industry scale using DevOps. Okay, okay, so correct. And from about the question of Abhishek. Yes, AWS. Yes, AWS, GCP, a lot and all. They cost a lot. I understand, but you have to be aware about what services you're using. Okay. For example, if you go ahead right now and create an account in AWS, you will get a 6 month period which is free, and you'll get about $130 of credit, which is enough for 6 months. Okay, which is enough for 6 months for sure. Okay, you have to avoid a few services, I would say, which are very expensive. For example, in AWS, RDS is very expensive. Okay, that's that, but you can obviously try it out, but you have to make sure that whenever you're using a service, okay, because you're using it for learning purposes, right, when you use a service, turn it off afterwards. If you just turn it off afterwards, it will not cost you anything. In AWS, everything is like priced according to your usage. If you don't use it much, you're not going to be charged much. Okay, you're not going to be charged much. So that's why whenever you start an application, close it when you don't need it. Okay, so you can turn off EC2 instance. One thing in database, you have to delete the database as well, because you're charged for the size of the data as well. Okay, so with every service, just have to be a bit aware about the billing and all, right, and you can very easily learn it for free. Okay, when you create an AWS account, you have to make a UPI mandate. One more thing I'll have to add, and that can be done by just spending 2 rupees at once, and that also comes back. And for safety, you can just remove the mandate afterwards. Okay, it's fine, because you'll not be charged for 6 months. It's fine to remove afterwards. Okay, so that's how I have used AWS for free, and you can also do it. Okay, so just be aware about the services, the bills, and second of all, just create a mandate and delete it afterwards. Okay, you don't even need a credit card to use AWS now. Okay, so let's go ahead with our session. Okay. Okay. Any alternative of RDS? Yes, you can use Supabase. Supabase Postgres is amazing. It's free. I personally prefer that over RDS. Okay. Vishal, can you make sure that my slide is visible again? Please check. Vishal, hello. 1 second.
No, sir, your slide is
Check.
not visible. Hello? Yes, sir.
Yeah, I have shared it. 1 second. Now, all right. I think I'll have to share it through this only. Is it visible now? Let me check. I've shared through both.
No, sir. Still same.
Yeah. Yeah, visible now. Okay, so it's visible, right? My
Yes, sir, is visible now. It's visible now.
okay, it's fine. Fine. So now let's talk about the roadmap and how to become a DevOps, right? How to become good at DevOps, right? First of all, I like to really point it out that if you are a student, right, and if you are a very junior developer as well, learning DevOps is the short way, I would say, to transition into a more senior level roles. Okay, so let's just talk about how, first of all, you can become a DevOps engineer, and become good at it, right? So the first step is, mastering the foundation. Okay, so see, in DevOps you're working with deployment pipelines. Okay, and you might be aware that the deployment pipelines, right, are mostly in Linux. Okay, they're mostly in Linux. So for example, if you use AWS or GCP, you would be having Linux as the main operating system. Okay, so the first thing is understanding Linux CLI, I would say command line interface. Okay, so basic navigation between the folders, creating the folders, permissions, extremely important, right? All these steps in Linux are extremely important. So the first step is, in foundation, understanding Linux. Okay, and basic scripting in Linux, right? That's called bash scripting. Okay, so in Linux you can do a lot of stuff in scripting. So Linux and bash, I would say, is extremely important as foundation. Okay, it's not going to take a lot of time to you, for understanding Linux and some basic scripting language, right? So for example, bash scripting is just like, any other programming language you might have seen, and it's much simpler. Okay, the third is basic networking concepts like SSH. Especially I would say SSH, because every single time you have to log into a EC2 instance or any other, I would say, virtual machine, you use SSH itself, right? You use SSH. This is a specific protocol made for controlling remote service, right? Then all these different protocols like TCP, IP, DNS, HTTP, etc. You have to understand why. Because when you set up your servers, right, you have to configure its networks. Okay, whenever you set up a server, you have to configure its networks, and you don't understand the networking concepts, you will not understand what are you configuring itself, right? So it's very important to understand basic networking. Okay, and most importantly, I would say Git. Okay, now, I told you about how you do a basic level deployment, right? Okay, that's using in AWS. You first log into AWS, so you will probably do SSH into your instance, and then you will do a Git pull to bring all your code inside the instance, right? So Git is extremely important. First of all, it helps you manage your code base into different versions, and second of all, it's a very good tool for transferring the code from your local machine to someone else's machine, and that includes a remote server. Okay, so these four make up the foundation of a good DevOps engineer. That is Linux, Bash, networking, and Git. Okay, these four, they matter extremely. Okay, and this you can learn in quite a short period of time only, right? I would say start with Linux. If you're comfortable with Linux, go forward with Bash, networking, and obviously Git. Okay, and once you are comfortable with Git, right, start using Git in every project. So the Git, personally as well, I was not very comfortable with Git in my college years. Okay, I got comfortable with Git only when I started using in companies. Okay, so the best way I would say of learning both Linux and Git is to go ahead and practice a lot. And whether you practice in a company, in an internship, or you do it yourself in a personal project, doesn't matter. But you need to practice a lot. Okay, so these four make up the foundation of any good DevOps engineer, and without this, you can't really move forward. Now, the second thing is building CI/CD pipelines. Okay, what is CI/CD? Okay, so it stands for continuous integration and continuous deployment. Okay, now I have talked about how you do manual deployment, right? And you saw that there are many steps. Okay, the first step was to actually build the jar file, for example, in Java, or build any create the build files, right? And then the next step was to actually go ahead and run them. Okay, so CI/CD pipeline is the way of automating that entire thing. Okay, so you have things like GitHub Actions, which can automate the whole flow. Okay, so for example, let's say if there's a push at a particular branch, okay, uh, let's say there's a push at a particular branch, the whole pipeline will start automatically, right? It will do all the step that we have done. For example, logging into your EC2 instance, do a Git pull, then maybe run commands to create a build, for example, for jar files, and then run it. Okay, so all the steps are automated with CI/CD pipelines. So basically, you first saw automated deployment, and CI/CD pipeline is basically automating the whole deployment process. Okay, and there are many tools. For example, I've written over here GitHub Action, Jenkins, GitLab CLI testing. So you don't have to learn all the three. Jenkins, GitHub Action, GitLab CLI are basically doing the same thing, I would say. Okay, the easiest one to learn in this age is actually GitHub Actions. Okay, it's the easiest one. You don't need any particular server setup like need in Jenkins. So my suggestion would be to learn GitHub Actions first, and then according to, let's say, a role, if you're targeting a role, they require Jenkins, go ahead and learn Jenkins. GitLab CLI is not used that much. It's used in very specific companies, but Jenkins and GitHub Actions are industry standard, I would say. Okay. And then testing is required everywhere. Okay, it's irrespective of whatever you want to do, testing will be required everywhere. Okay, so in a CI/CD pipeline, what happens is you push your code. Okay, it is tested, both the unit test, integration test, everything is applied. Okay, then it goes to a CI/CD pipeline. Then it goes forward, right, and creates a build out of it. That is, maybe it can be a jar file, it can be a Docker image, whatever. Build can matter, how you're building it, it will vary on that. What kind of project it has, is it a MERN stack project, is it a Python project, Java project, the build will actually vary on that. And then you go ahead, SSH into your server, and then deploy your application. Okay, so that's the whole CI/CD pipeline, and that you can write with GitHub Actions. Okay, so as we talked about, first step is understanding the basics with Linux and Bash, networking, Git, and all. Second is learning Git, CI/CD pipeline. And as I have said, you don't have to learn all the four of them. Start with testing and GitHub Actions. If you have time, if you are get comfortable with these two, learn Jenkins. And GitLab CLI only learn, let's say, when you are targeting a specific company, it's using which is using GitLab, then you can go ahead with this, right? Okay, so just these two, GitHub Action and testing would be enough for this case. Okay, now the third thing is containerization. Okay, now so when you are pulling your code from your local system to a remote server, you can have a lot of issues, right? For example, right now I'm using a Mac, but my server is in Linux, is in a operating system called as Amazon Linux, or let's say Ubuntu, right? So and there are possibilities that dependencies between my machine and the server can vary. Let's say I have Python 3.9, and my server can have Python 3.7, for example, and some features just work on 3.9. So what will happen is it will work perfectly fine on my machine, right? But when it goes into deployment, right, when it goes into deployment, it will just crash, right? So dependency management is a very big problem. It's a very big problem. And to solve it, we have containers. So what containers do is basically keep your code along with all its dependencies, all the system files that you need in one place, right? So whenever you start a container, create an image, right? What happens is that all the dependencies that you need with correct versions and everything is available to you, is available to the machine, to your code base, and it works perfectly fine anywhere. Okay, so what you do is you write your code, you write a Docker file. Docker is a containerization software, right? Write a Docker file and then create a Docker image, right? And then whenever you will run that Docker image, it will run same everywhere. Whether you run it on Windows, whether you run it on, let's say, Linux, whether you run it on Mac, on any version, because internally it has every single file that it needs to run. Okay, so that's the benefit of using containers, right? So the next step is understanding those containers, virtualization, right, and understanding Docker really well. Docker, and one more thing is Docker Compose, right? Docker Compose and Docker helps you. Docker Compose basically lets you run different images together. For example, if I, let's say, have a full stack application, so I would be having a backend, a front end, a database, right? All these three would be their own images and they need to interact with each other. That's where Docker Compose comes in. Okay, now Kubernetes. If you want to become a good DevOps engineer, Kubernetes is sort of must. Now, what Kubernetes does, it actually helps you manage this whole set of Docker images, right? Because you will not have, first of all, just one server, right? Kubernetes handles image distribution, running the images on multiple servers, okay, on multiple servers. So that's where Kubernetes comes in, an extremely important tool that you need to learn. Then Helm. Okay, Helm is actually, I would say, a way to easily run Kubernetes, right? It's a package manager, you can say, for Kubernetes. Just like for Python you have pip, For let's say Node, you have npm, right? Similarly, you have Helm for Kubernetes. It helps you download a bunch of things that you can get started right off the bat. And you don't have to make everything from scratch. Okay, so that's all I would say that you need for container orchestration. Security, it's important, but it's actually quite high level. You can leave it for now, right? And there are tools that can do it for you. For example, this a tool called Loki from Grafana that can do it for you. So okay, I did not understand your question. Can you repeat, please? Empty question is revolution effect. Can you please repeat? Okay. So let me go forward with this. So our steps till now is foundations, CI/CD pipeline, and containerization with Docker and Kubernetes. Extremely important, right? Now, then you have to apply this on any cloud, right? You have to apply this in any cloud because to deploy you need a machine to deploy it, right? So these cloud companies basically rent you out the hardware in which you can go ahead and deploy this, right? And that's where basic understanding of cloud and infrastructure is very important. Okay. So for example, understanding of basic AWS services like EC2, S3, and all, right? Because you're going to use them a lot, right? So understanding of basic AWS services pretty important because you're going to deploy on them only. Then comes things like Ansible. Okay. Now, what is Ansible? So, for example, in your, let's say you are creating a server. In that server, you need Python, you need, let's say, Docker, you need, let's say, Node.js, etc. You need a set of things, and you want to automatically configure that server. That's where you use Ansible. Okay. Honestly, man, I'm not understanding your question. My question is IT revolution affect MT8 career. What does it mean? Okay, please frame it correctly. And I'll continue in the meantime. The third is understanding Terraform. Okay, so what is Terraform? So let's say you make your own whole architecture on a cloud, right? But you get cloud dependent. Okay, so let's say my entire architecture is on AWS. So now I am cloud dependent. If let's say AWS goes down, my services are down, right? So to not get completely bounded by a cloud, we use Terraform. Terraform is whole infrastructure as a code. So for example, you need databases, 3 instances, you need this and this servers and stuff. All the details are written in a Terraform file, and that can be easily replicated in any other platform. So you just upload your Terraform file, and the cloud will do everything for you. So it will create the entire infrastructure needed to run. Okay. So this is what you need to understand about cloud and infrastructure. Uh, you know, and this might take some time, okay, because in the Kubernetes section will take time, the cloud section will take time because it's easier said than done. It's a lot of things in them itself. For example, AWS core itself has so many services you need to understand. For example, S3, EC2, um, RDS, Lambda, all these things you need to understand. So it's going to take some time, but once done, it's going to be of extreme value for you. Okay, so let's revise. Till now, foundation, CI/CD pipeline, containers, cloud, and then finally observability. Right now, this is also is a extremely important part of DevOps, is actually managing your application. Okay, so for that you need to continuously monitor it. Yeah, you can see a virtual machine is basically a computer. Okay, a virtual machine is basically a computer. You can run multiple jar files in a computer, right? You can run it in virtual machines, but you have memory and constraint. Like for example, let's say you have just 8 GB of memory or let's say you have some compute. If that limit memory, let's say, uh, completes, I would say, right? So let's say you have a jar file that takes 16 GB of RAM. It will not work in a 8 GB virtual machine. That's all. So so you can run multiple jar files. You can run a Java plus you can run, let's say, a Python application in the same virtual machine. All that is possible. Okay. But yeah, it's resource constraint, right? If the resources are wiped out, it will not work fine. Okay. Now let's come to monitoring and observability. So basically, uh, let's say your application is running, right, and it will be continuously producing some logs, right? It will be continuously producing logs, and the problem with large scale projects is that there is not just one dashboard inbuilt that you can go ahead and check logs, because your application is running across a cluster of servers, maybe 10 servers, 20 servers, 30 servers, depending on your scale, right? So you can't go ahead and look at each log independently. So you need some softwares which can pool all the logs from all the servers, all the pods, and then show it at one place, right? It will obviously increase, right? As I told you, it's the cost is basically actually it will not increase, I would say. Yeah, it's not going to increase. Whenever you create a EC2 machine, right, a virtual machine, it cost depends on the time it will run. Okay, it depends on the time it will run. The only problem we'll have with running multiple, let's say, images together, okay, is that your resource will be used a lot. Okay, so it will start crashing very easily, because let's say both are competing for the same RAM and the same CPU, right? They will start crashing. So if you have, let's say you don't have users, you can do it. If you have users, you can't, right? It will start crashing. Okay, that's all. Okay. So where are we? Yeah. So to monitor your logs and all, you need a bunch of tools like Prometheus, which sort of scrape all the logs together and show it to you. There's also a concept of log level, right? For example, you might have seen this info, error, warning. These are log levels. So you can also filter by log levels and understand the severity of a say, case, right? So all these things can be done by Prometheus. Now you also have things like Datadog, Grafana, ELStack. All these applications, I would say, focus just on Prometheus and Grafana for now, right? These are open source and you can learn them quite easily, right? Datadog and Jagger are, I would say, they are paid in most cases, and I've used them mostly in companies. But Datadog, it's an amazing tool. Okay, it shows you how your API request happens, all the layers it goes through, the response time at each layer, the compute that's happening. So it gives you a very detailed overview of what's happening and what might be slowing your application down, right? So this is, I would say, the fifth portion is for you guys, because you guys are in I would say, mostly I would say, in college, right? So fifth might be optional for you, and you probably will not be able to do it properly, because it really needs a lot of data to work with, and that comes sort of in a company itself. So it might be optional for you, but it's a good thing to understand Prometheus and Grafana, right? And you will get its real value, its real experience when you start working in the industry. Okay, so yeah, that's all. Say. And yeah, sixth is called as DevSecOps, right? That's basically DevOps with security. There are a lot of tools here. As I told you about, Loki is one of them, right? And this also handles the security layer along with deployment. Okay, so it makes sure that your code is not only, let's say, what do you say, it is deployed properly, it has zero downtime, but no security vulnerability are sent over here. Okay, again, sixth is a little optional for you, but learning them, understanding the concepts would be good. Okay, now one thing mentioned over here is SRE principles. I feel this is something, if you know this, for an interview perspective, your level will be something else. SLI, SLO, SLA. Now these are not really technically very advanced. I would say they're not very technically advanced. Just theories, but if you know them, it's an amazing thing to know. Okay, so I think it ends here. Yeah, it ends here. Okay, so let's see the whole summary. You first work on the, foundational things like Linux and all, Git, then CI/CD pipeline, containers, cloud, and infrastructure as code, that is Terraform, Ansible, right? And then you go to monitoring like Grafana dashboard and all, Prometheus, and then next is security. Now, as I told you, for you to become a good engineer, you have to do from 1 to 4. That's mandatory. 5 and 6, I would say you can skim over it. You have to actually skim over it and understand the basics, the theoretical part, right? Because in practical you will not be able to mostly generate all the scenarios that you would need to really learn them. Okay, so I would say phase 5, phase 6, you have to basically go ahead in a company and learn this. But till 4, you can learn it in your home. 5, 6, you can understand the theoretical concepts really well. Like for example, SRE principles. You can get comfortable with Grafana dashboard and get comfortable with Prometheus, right? And understand a lot of dev security, vulnerabilities that there are, right? What type of functionality improve after apply 6 stage? Hmm. I'm not sure what your question is. Can you repeat? And yeah, that's it, guys. So we are done with the whole, I would say the structure in which you need to study. Okay, and that's all from my end. If you have any questions, you can please ask me, and we are done, right? Okay. Okay, so I got you now. So basically, after this phase 6, right? Why this phase 6 is needed? Okay, so let's say you push a particular code. Okay, so you might have heard about a term called as OSAWP, right? So it's a security standard. Okay, um, which is a standard for all the best mode, or I would say code quality for security purposes, right? So these you know tools in security try to find standard pattern of leaks standard pattern of leaks or standard pattern of security issues, right? For example, in a code, let's say it is susceptible to something like let's say SQL injection. Okay, so this DevSecOps tries to find the code vulnerabilities like SQL injection and other vulnerabilities in your code, and they trigger an alarm that okay, you have accidentally pushed a unsecure version of the code. Go ahead and fix it. That's the whole idea of security base. So what happens is when you deploy your application, before a hacker attacks you, you already get a warning by default. Warning, I would say, beforehand that there might be a security vulnerability in your system. You should go ahead and check it. Okay, so that's what happens after phase 6. Okay, any other question, guys? Okay. Okay then. Okay, guys, that's all from my end. Hope you understood the entire roadmap for DevOps and how you have to go forward with it. Okay, and I like to add one more thing, that it's important for everybody, I would say, to really understand DevOps, especially if you're trying to go into back end or front end engineering. Both people need to understand DevOps. So it's actually becoming, a requirement for a full stack engineer as well. So earlier you could have said that you're a full stack if you know, let's say, front end and back end, but now the full stack engineers are expected to also know about DevOps. And as I told you, it's a very easy way to increase your market value by an extreme margin. Okay. Also, I'd like to add one more thing. If you are looking for remote roles, right? Remote roles, especially, it's a crazy thing to happen, right? Because DevOps engineers in most countries are extremely highly paid, right? So a sort of an arbitrage occurs, that you can, from India, do work with a lot of remote American startups, right? And you can provide your services to them, right? So DevOps is actually a cream layer over there. So definitely target all of them, learn DevOps, and you can target all these companies, right? So, because where will you deploy then, right? So AWS, GCP are needed, because that's where you will go ahead and deploy these things, right? DevOps is, as I told you, it's basically understanding the pipeline of deployment. But where are you going to deploy? So either use AWS or GCP, or otherwise you need to set up your own server farm. So that's in most cases impractical to set up, right? Some companies do have their own, I would say, cloud infrastructure, but most don't, right? It's very expensive to set it up. That's why they use AWS and GCP. Okay, okay then. Bye everyone. We will wrap it now. Okay. Okay. Yeah, that's it, guys. Thank you for joining. Bye bye.